Okay, for example 2, the tension in the exercise band varies proportionally with the stretch distance. The tension T is described by the function T of x equals Kx, where K is a constant that depends on the elasticity of the band, and x is the stretch distance. Which position shown in the figures has a greater tension in the band? So, here's a formula. T of x, now it says the tension T is described by the function T of x. T of x is T, so this is just called functional notation. They do that sometimes in algebra / geometry books. They'll take a variable and they'll create a functional notation for it. So T is the variable, it's a variable of x, which is the second variable in the problem. So T of x could easily be called T also, so don't get messed up with that. So T is the tension, so we're trying to determine which of these has the most tension. And then there's this K and X in the problem also. K is a constant that depends on the elasticity of the band. Okay. You guys know what a constant is? If something's held constant, what happens to its value?
It stays the same.
It stays the same, it doesn't change. So anytime you describe something as a constant, even though I don't know what K equals, I have no idea what K is, and you guys don't know what K is, but no matter what K is, it's a constant, it's going to stay the same. So if K is 5, it stays 5 forever. If K is 2, it stays 2 forever. So a constant, a variable representing a constant should be considered just like a number would be considered. It's just not going to do anything, it's just a numerical value. We don't happen to know what it is at this moment in time, but that doesn't matter. Anytime something's held constant or is a constant, it means it will never change. Okay? And then X is the stretch distance. The stretch distance would be how much we're stretching the band. So X is the length of KL, X is the length of KM. Okay? Now, X is changing, right? So X is a variable. So when you're considering an equation that they're giving you, you should consider what values are changing, those are variable values, and what values are staying the same, those are constant values. And anytime you're asked to describe something happening or figure out what's happening, you should focus on the variables, because that's what's going to change, that's what's going to give you some different information. So we can see from the pictures that we have a 50-degree angle here in this, where JL and JK are the other two sides. And then 80 degrees, we got JM and JK. So obviously JK is the same as JK. It's the distance from his feet up to his shoulders, feet to his shoulders. JL is the length of his arms. I don't know why they don't call that L also, but they call it M. I guess it's a different spot, that's why. So L is here, M is here, different spots, that's where you're using different letters. But they're marked congruent, JL and JM. So his arms did not grow as he went like this, right? They stay the same length. So we can see here the smaller included angle is 50, the bigger included angle is 80. So I know for a fact that LK should be less than MK, right? Hinge theorem says if two sides are congruent and their included angles are not congruent, the bigger side is opposite the bigger angle. So 80 is bigger than 50, KM is bigger than LK. You can also say LK is less than MK. It doesn't matter what order you put that inequality. All right? X is being multiplied by K, so the bigger X is, the more the tension is, right? So again, K is always the same number. If I multiply some number times a bigger number, I'm going to get a bigger product, right? So I'm considering what's the greatest tension. We're trying to make this the biggest it can be. So if X is bigger, multiply bigger times K, you're going to get a bigger answer than if you multiply smaller times K. We all buy that? So which of these has the greater tension in the band? I'm going to say JKM, called triangle JKM, has greater tension. So how to describe the figure you want to pick. So the one with the 80-degree angle has greater tension. Take your pick how you want to describe it, but that one there is the one with greater tension. Because X is larger, KX has to be larger, and KX is what T is.